Recently, the U.S. Air Force announced two new drone models named YFQ-42A and YFQ-44A. This is the first time the U.S. military has officially assigned codes to unmanned combat aircraft, marking an important step forward in the development of modern combat vehicles. According to the plan, these aircraft are designed to coordinate with fifth-generation fighters in future air combat missions. So, what outstanding features do these two aircraft models have? What role do they play in the modern air combat context? Join me, the host with the nickname Windthroat, to explore details about the U.S. military's new pair of drones in today's analysis. In recent years, the U.S. Air Force has not only focused on developing next-generation fighters to maintain air superiority, but also promoted projects to build coordinated combat aircraft, also known as CCA, Collaborative Combat Aircraft. The two aircraft models, YFQ-42A and YFQ-44A, are the latest results of this program. First, we need to clearly understand the concept of coordinated combat aircraft. This is part of the U.S. Air Force's strategy to prepare for competition with other powers, with the goal of quickly expanding the size of its fighter fleet. The U.S. Air Force believes that, to deal with strong opponents in modern warfare, they need to maintain an air force large and strong enough. However, reality shows that aircraft models such as the F-15C or A-10 are gradually becoming obsolete, while the number of unmanned fighters purchased in the future will be double that of manned aircraft. Therefore, the development and deployment of a large number of drones is urgently needed to compensate for this shortage. This situation is somewhat similar to the challenges the U.S. Navy is facing in shipbuilding, although the severity is not as serious. Both YFQ-42A and YFQ-44A aircraft models are designed according to modular principles, helping to significantly reduce production costs, with an estimated cost of only half to a quarter compared to the F-35 fighter. Thanks to this price, the U.S. military can produce them in large quantities. U.S. Secretary of the Air Force Kendall once revealed that the Air Force plans to build a fleet of 200 NGAD fighters, 300 F-35As, and about 1,000 CA combat coordination aircraft to replace current tactical aircraft. In other words, each F-35 will be supported by 2 CCA aircraft on average. To date, the U.S. Air Force has announced a number of CCA models, including familiar names such as XQ-58A or MQ-28A. Most recently, 2 new drone models from 2 companies, Anduril and General Atomics, were introduced, and today we will take a closer look at their performance. Regarding technical specifications, the YFQ-42A, developed by General Atomics, has a length of 4.5 meters, a wingspan of 8.5 meters, uses a small tail design, and a large air intake arrangement on the back. This aircraft does not have a horizontal tail and is developed based on the XQ-67A platform. Its maximum takeoff weight is 1,200 kilograms, with a continuous flight time of up to 36 hours. Meanwhile, Anduril's YFQ-44A is larger in size, with a fuselage made from carbon fiber, about 6 meters long, a wingspan of 5.2 meters, and a maximum takeoff weight of about 2,268 kilograms. This aircraft is equipped with a Williams FG-44-4 engine, an improved version of the parent aircraft's engine, helping it reach a maximum speed of 0.95 Mach. However, the flight time of the YFQ-44A is shorter than the YFQ-42A. The most obvious difference between the two aircraft models lies in the position of the air intake. The YFQ-42A has the air intake on the back, while the YFQ-44A is located on the belly. This design reflects the difference in technical priorities of the two aircraft models. The YFQ-42A with the air intake on the back has better stealth capabilities but is susceptible to airflow problems, leading to limited maneuverability, especially the inability to perform flights with large overloads. In contrast, the YFQ-44A with its ventral intake has better maneuverability, but due to the use of only one vertical tail, the stealth effect from a side view is affected. Regarding the ability to carry weapons due to their compact size, both aircraft can hardly accommodate medium-range air-to-air missiles in their internal weapons compartments. Instead, They must carry weapons under their wings, but their load-carrying capacity is quite limited. In addition, the small nose of the aircraft prevents them from mounting high-power radar, leading to a heavy reliance on manned aircraft or early warning aircraft to guide and detect targets. In the case of coordination with manned aircraft, F-35 pilots will be under great pressure because they not only have to control their own aircraft and weapons, but also have to lead and control unmanned aircraft. With just one small mistake, the coordination between manned and unmanned aircraft can be broken. Furthermore, the stealth capabilities of these two aircraft models are only average, so if they lose command from manned aircraft, they will easily become targets for the enemy's 4th, 5th, or 5th generation fighters. Currently, the U.S. Air Force is planning to buy at least 100 to 150 CCA aircraft, with the possibility of increasing the order depending on the situation. In addition to General Atomics and Anduril, large companies such as Boeing or Lockheed Martin have also proposed their own designs but did not make it to the final bidding round. It is still unclear whether the U.S. will choose the YFQ-42A, YFQ-44A, or both models. According to the U.S. military's strategy, these drones are designed to coordinate with the F-35 or future 6th-generation fighters, but at the present time, they are not really ready for that role. With their current configuration, it is difficult for both aircraft models to achieve perfect coordination with 5th or 6th-generation fighters, mainly due to limitations in flight performance and aerodynamic design. Both use straight wings, making them unable to fly supersonic, and their small size also limits their range. Therefore, their main role today is probably just to supplement firepower for the F-35 or confront enemy drones. Even if used as aerial decoys, they are also a viable option, although the cost for this purpose is somewhat expensive. However, U.S. Air Force leaders emphasize that the YFQ-42A and YFQ-44A are not the end of the project. In the future, they will be upgraded with many new features to perform more diverse tasks. The essence of the coordination strategy between manned and unmanned aircraft is to create a combination of expensive and low-cost platforms, or coordinated high-low. The U.S. can deploy large numbers of cheap drones to form air defenses or lead attacks, thereby putting pressure on enemy air defense systems. Meanwhile, manned aircraft will operate outside the danger zone, commanding drones to penetrate enemy defense areas to carry out distributed attacks, paving the way for the next round of combat operations. In addition, these drones can also take on the role of reconnaissance, information gathering, electronic warfare, or even jamming and deceiving the enemy, thereby improving the effectiveness of combat coordination. To achieve this goal, the cost of drones needs to be kept very low. The U.S. Air Force requires their price to be only half to a quarter of that of the F-35A, which is about 20 to 40 million US dollars per unit, based on the 77.9 million US dollars price of the F-35A. Although this price is still not cheap, compared to previous projects such as Boeing's MQ-28, it is much more reasonable. However, I think the greatest development potential of drones lies not just in their support role, but in their ability to achieve performance equivalent to manned aircraft. They can both be assistants for manned fighters, and can also take on an independent role when necessary. In particular, more advanced drones in the future can even become mother aircraft, controlling flocks of microscopic drones to attack or destroy the enemy's advanced weapons, thereby gaining an advantage on the battlefield. However, with the current level of technology, this scenario still needs more time to become reality. Overall, the YFQ-42A and YFQ-44A are America's first unmanned combat aircraft, demonstrating the potential of modular design and interoperability. However, they also exhibit limitations such as conservative aerodynamic design and low autonomy. Their core value lies not in creating a perfect platform from the start, but in accumulating experience and data to develop future generations of more advanced drones. With the advancement of artificial intelligence and stealth technology, these aircraft could become the center of future air combat systems, but at the present time, they still need close support from manned aircraft to maximize effectiveness.